So I'm here to speak on open source software and supply chain security. And here we go. All right. So who am I? My name is Divya Natesan. Like Catherine mentioned, I'm a technical director at NCC Group. What that means is, as part of my responsibilities, I lead teams for pen testing, architecture reviews, and things like that that we do with clients. I'm also the North America Regional Director for a specialized practice that deals with containers, Dockers, Kubernetes, orchestration, anything in that world. And what NCC Group is we are a cyber consulting firm. We work with a lot of different clients to help make their products secure. That is the main goal. And then we have around 14,000 clients and worldwide presence. There is a big presence in the UK, and there's also a big presence in America, and apart from that, in Australia as well. And we have around 2,000 employees. All right. So getting into open source software landscape itself, I know Peter here was mentioning a lot about open source software. So this is going to sort of like take it from there and move into the security realm of things. Yeah, so open source landscape, like Peter was mentioning, is super, super large, right? And it's great because it embraces all the good principles about open exchange, collaboration, and like in general, anything around community-oriented development. Because imagine somebody had to build a product from scratch without using any libraries or any open source software, right? That's not going to happen. It's going to take years and decades possibly, right? So like you take a networking tool, you're probably just going to use a PCAP parser if you want to like look at like protocol data or something of that sort. You're not going to actually start building that from scratch, because of which why open source software is great. But since I'm an in and out security person, right, I look at it from the perspective of how secure is consuming any open source software out there in the landscape. And that's what I'm going to be mostly talking about. And this GIF is like super awesome because I typically envision open source software layers in security like a peeling an onion, right? Because you think you have a product which uses an open source software, which uses another open source software, and so on, right? So from a security perspective, you got to actually look at all the different layers, which a lot of people don't do. Okay, so I sort of talked about this now, right? Security challenges, but essentially there is a high risk, like using any software, also in the open source software landscape, about actually using libraries in your products. And typically, we say open source software is all about transparency. That's great. But then that must also mean that it's probably vetted, it's probably secure. It's like the impression people have, which is true. But in a typical software development lifecycle for anything open source, for example, right? Like a PR is reviewed, and so you can say, hey, the PR is reviewed, so as somebody must have looked at my software or before merging into the main branch, so that means it's secure, right? Well, like the PR is generally reviewed from a development mindset, right? So people are looking at, is this going to break things? Is this a good feature add? And things like that. And possibly we'll pick on like some low-hanging fruits in security, but not really all, right? And that's where security in open source fits in, and the risks there are. So also there's like a lot of products that obviously use open source software, right? And they also have like internal security teams that possibly can also look at the stuff. The problem with that is internal security teams, like we all know, are generally very swamped for time aspects, because there's a lot of different product features within their own organization they have to be looking at. So they may not have enough time to analyze, do a source code review, for example, of like an open source library, and make sure they say, hey, this is good, we have looked at it. So that's a challenge security folks also face quite a lot. So what a good exercise in my mind is actually to perform an initial risk assessment sort of thing by the internal security teams of organizations. So this could be just performing an architecture security review and threat model to understand what are the different open source softwares my product is consuming. And say, for example, what is the threat model looking like? Am I giving that library a lot of privileges that it shouldn't be? What kind of data can my open source software, that library, if compromised, can actually access? That sort of questions, answering that would give you a perspective from a product, product standpoint, product security standpoint, in terms of, okay, where is the threat lying for me from an outsider threat perspective and an insider threat perspective? And there's obviously dependency analysis, which I was talking about, peeling the layers of the onions, right? So looking at what is the whole stack of different open source software that I actually use. Yeah, in terms of, yeah, I think I mentioned about the supply chain. Another great exercise is actually trying to look at, hey, I want to use this open source library. So there's two different things, right? The library itself might have vulnerabilities, but the library might be great, but the way you implement it might also have vulnerabilities, right? So it's really also looking at how to implement those open source software products. So it may be looking at other teams in your organization, or it may be actually looking at other peer organizations and see how those, those libraries are actually implemented. And that's generally also a great exercise in addition to architecture security review. Yeah, and why is this important? Because lots of times, maybe you have a very sophisticated product with a very sophisticated internal security team, right? That does a lot of vetting on your product. You're super confident about your applications, your services, your network, and all that stuff. But sometimes the weak link would be in the open source software, right? So maybe not enough people have looked at it. Maybe it's not a super popular library. And maybe compromising that might mean, keys to the kingdom for your product, so which would actually impact your product, right? So it's always good to keep that in mind, along with everything else product security that you're looking at. All right? Okay. Yeah, this is a very cool slide. You can mostly just Google all this information. I thought I wanted to sort of talk about open source security breaches and mainly supply chain security breaches in the past, just to open your eyes to how massive can this be. Is it just like a vulnerability in a product I'm talking about? What kind of impact it can have? Starting with my most favorite, the old ones, right? Like from 1959, some of them are physical, some of them are software hacks. So CIA intercepted the USSR lunar probe in the supply chain, right? And within 24 hours, they were able to actually disassemble everything, document, understand what is in the lunar probe, assemble it, and send it back without any trace of that being done, right? So that is a big physical supply chain security flaw right there, that there was no monitoring around that stuff, right? So that's a great example of supply chain security breaches. Another one, this is a popular one with software security stuff. There was a third-party vendor credential compromise for Home Depot, which means that Home Depot software wasn't compromised. It was a third-party vendor credentials that were compromised that ended up leading to compromise of, I think, 56 million credit and debit card numbers, which is super huge. And the next one is, again, a physical one, where there was a microchip inserted by a state actor, and that was never part of the original design, and that actually went into distribution, right? So that's, again, nobody at that point knew what the microchip was doing. Was it a backdoor? Was it exfiltrating data and all that stuff? And then the most popular of the recent times, SolarWinds, I actually have an entire slide to talk about it because it's super interesting, which is also something around build chain compromise, and that meant that that network software actually had a widespread compromise on everybody that was actually using it. And the 2021 one is actually, this is, I think, it's not confirmed which party did this, but it was mostly a backdoor that was placed in the open source PHP Git server. And it went unnoticed. It went unnoticed for a while, but it was then caught before publishing and distributing, which is good. But it's also another example of software supply chain security flaws. If it had happened and if it had actually been distributed widely, then it would have affected millions of web servers, because obviously it's the PHP Git server we're talking about. All right. Okay. So like I said, the slide on SolarWinds, there's a lot of data in it. You can look at it later, but the gist is basically SolarWinds is a software company that does systems management software within networks for IT companies and things like that. Has around 300,000 customers, has a lot of heavy lifters, has people from defense, US government agencies, lots of Fortune 500 companies, top 10 telecom companies and things like that. And because of the SolarWinds supply chain breach, there was around 18,000 of those 300,000 customers that were compromised. That was massive. And there's probably a lot of you in this, in this room, trying to actually patch up and actually understand what happened, with the SolarWinds supply chain breach. Was your network compromised and things like that. This is a very interesting attack because it was also a very sophisticated ATP. So it was not just about actually developing a malicious backdoor and actually getting it installed in different different targets that SolarWinds is actually used in, but it's actually beyond that, because even after installation, what they did to actually make sure that they don't go detected, and how there were no trivial IOCs that you can get out of it and like have TTPs, was actually the more challenging part of the SolarWinds security breach itself. So what happened is the adversary compromised the CI/CD pipeline, the build pipeline, and in short, they were able to actually get their malicious backdoor in there without actually compromising the source code, because of which what happened is anybody that uploaded or updated their software, which was the Orion software, which was actually their network management software. What that software is it basically sits on your network and tries to monitor like infrastructure in your network, and tries to also take, like there are features you can configure in the tool where you can actually say, okay, I'm setting response. If this happens in my network, I'm going to try and prevent it or do certain things, right? Which means it is a privileged sort of, it sits in a privileged position in your network, so it can actually take action on things in the network. So if you end up being like a malicious backdoor in SolarWinds, or you end up being somebody that can compromise like privileged credentials there, right? Then you can do a lot of damage in the network in terms of what you can breach. Like I said, the interesting thing about it is, once the update is done, for 12 to 14 days, there was actually like no action. Everything seemed to work like normal, so that they can go undetected. Because like lots of times when you update software, there's like SRE teams that are going to be looking at, okay, is everything functioning properly? So there's actually a little more, like, like people look at logs a little more and things like that. So they want to go unnoticed. And after 14 days is when it started sending its beacons. And it was target specific to different clients, right? So like from a security perspective, it is a very interesting one. But essentially, the big picture I'm trying to paint here is, like, you can have simple security vulnerabilities. You can have super difficult ones that actually end up being very difficult to detect from an incident response perspective. And all of this, not even like, related to your product, right? You're just updating a different product that you use, and all this bad stuff can happen. And you can actually end up, gaining things from that target network, which is your network, right? So that's why it's important to keep in mind the supply chain aspect of it and open source software aspect of it in terms of security. Okay. Yeah, so what kind of security vulnerabilities can we actually see if somebody audits OSS, right? And this is something I spoke about a little bit in the last slide. But essentially, the quick answer to all of this text in the slide is pretty much anything, right? So it's just like any other software. So you're going to obviously try and analyze it from a threat model perspective and see, okay, is the OSS actually rightly configured in my product, right? Or is the open source library actually only exposing the bare minimum functionality in the default install, right? There's a lot of libraries out there where you just like install something, and then it'll like open up a bunch of ports, do a bunch of things that you don't necessarily want in your product, and then you don't realize it, and later as a pen tester, we go in, and then we notice there's all this attack surface that doesn't necessarily need to be there, right? So that sort of a threat modeling architecture risk assessment is also a very good idea. And obviously, we saw a lot about maliciously injected backdoors. What else? Yeah, and obviously, there's the dependency onion that I was talking about, where you have one open source library using another open source library and so on. So you got to obviously take the whole picture and not just the direct library that you are using. And the last two are like pretty basic OWASP top 10s if you have seen like any application security stuff, right? So bad things can happen to open source libraries like it can happen to other products, right? So there was a case where there was this library that a product was using, and then the architecture was a little weird in the sense that you had both the intentionally exposed service and some admin service together, like bundled up, which without any firewalling or anything of that sort, right? So as you expose one of the services to the users that actually have to go in and access them, they can actually reach the other admin API endpoints, which is bad, right? It's not firewalled off, there's no authentication and things like that. So keeping in mind that those kind of normal attacks that you look at application security perspective for your product is also going to be applicable in the OSS world. So yeah, like all the regular stuff, authentication bypass, bad authorization, RCEs, any kind of injection attacks, TLS configuration, lack of encryption at rest or in transit, and all that stuff is like pretty basic that could go wrong. And then there's the CI/CD weaknesses, which I spoke about in the SolarWinds attack about the compromising the build pipeline. So that is also a very niche thing right now. People are trying to actually pay more attention to it because, obviously it could compromise, it could do a lot of damage. Yeah, and in terms of databases, there's another set of database security configuration things that you can look at, right? Is your default set of database roles doing the, following the principle of least privilege? Do you have anything super excessive that you shouldn't be having in there, which will let your customers configure those databases in a more insecure way? Those kind of things, apart from other infrastructure stuff like hardening servers and all that. Okay. So this slide is the second time you're seeing this today. I was excited to see that in Peter's slide deck as well. So this is the CNCF landscape on the left. So again, this picture is right here, not for you to be able to read every single box there. The intention is you can't read this. It's massive. This gives you an idea of the OSS landscape just in the cloud-native world, right? So just imagine the OSS landscape regularly, not in the cloud-native world. So the point here is trying to secure every single library there is super difficult as security consultants, as security people, right? So that's where we'll get into the next slide as well. But here you see in the right picture, I've taken a slice of the leftmost part of that landscape picture there. And you can see that TIKV and TiDB prominently mentioned here. So like Peter mentioned, they are one of the CNCF contributors that are actually out there top, which is great. And you see all these software actually have to still be looked at from a software security perspective. Okay, war story time. I know we're probably running behind, so I just have one slide on war story, and I want to quickly talk about an interesting sort of war story I've seen in my pentest times, and I've actually seen this multiple times that it's worth mentioning, and I feel like it captures really well, why you should secure open source software and things like that, right? So I was looking at a Kubernetes cluster for a product, just doing a general configuration review, and I did see that there was out of a bunch of different things, right? When you deploy something in Kubernetes, you're gonna get a lot of software and put stuff in it, right? So one of them was this OSS operator that I had seen that the manifest was actually installed in the cluster. And when I took a look at the manifest and the product installation steps, right? It had an RBAC manifest. So for those of you familiar with Kubernetes RBAC, there's this term of cluster role bindings and role bindings and things like that. And it had a cluster role binding that ended up giving you admin privileges to the entire cluster, right? So there's two things that are wrong with it. One is obviously the OSS operator has a lot of privileges that it probably shouldn't have, right? You have to have fine-grained access controls around what permissions that operator needs in the cluster to be able to do things. And the second is actually what it did was it actually associated the default service account in the Kubernetes cluster with those privileges. So, again, for folks familiar with Kubernetes, in the namespace, the default namespace is the one in which generally, if you don't specify a specific namespace, your pods and containers run in it. And this would mean that anything that runs in the default namespace, including services that were possibly spun up by the product team and they aren't aware of it, right? This default service account gets bumped up in terms of privileges. So all those services, other than the OSS software, also end up having superlative privileges, which is bad. It leaves itself in a vulnerable state, and it opens it up to other software to also be in a vulnerable state, right? That's the kind of damage something unvetted like that putting in your infrastructure could go wrong. And this is not just this is a very common war story, right? So I thought it's worth mentioning, and hopefully created that impact on why open source software security is really important and vetting that is very important. Okay, so obviously until now I've set the picture of, oh, this is really tough to secure all the things, but we have to do our our job on trying to actually make sure as internal security teams, as consulting teams, to be able to actually look at this from an architecture perspective, implementation perspective, and all that. And NCC helps a lot with that as well. So we do security reviews of a lot of different software for products and also for open source software. And one of the examples is the Kubernetes report. So we were contracted by CNCF to actually look at Kubernetes 1.24 and we have a public report out there, right? Initiatives like these, not just by NCC, right, but generally security consulting firms would actually like leave products in a better place to say, hey, you know, I feel safe installing this product, this specific commit hash into my environment because I know that it was already actually, you know, reviewed for security and things like that. Yeah, and like streamlining workflows to make sure that you can recommend to clients on how to actually secure data in enclaves, AWS Nitro, and all that stuff. That can also increase or improve the security posture of the products that you have. Yeah, and then one last point on the slide I want to mention is around real versus perceived threats. All this time I spoke about real threats, real war stories, things that can go wrong. And there's also the whole aspect of perceived threats. And perceived threats is going to be, you have insecurity about products because, you know, they're probably like several reasons, like state ownership and things like that, right? So again, that's where companies like NCC Group would fit in and say, okay, we can provide like an objective security analysis of this product, try to understand the data controls in this and see how it is secured, how it can be secured, and things like that. Again, another example for that is this is very recent. NCC Group has been announced as the third-party security provider for TikTok on Project Clover, right? Things like those. So, all right. And just, I think one of the last few slides, quick primer on, like, you know, NCC. We have, this is a pretty old slide, so most of the stats here are probably lesser numbers than it should be. We have, like, have a lot of public footprint in the security consulting world, over 100 talks, and that's, again, probably a very less number. In Black Hat, we are the firm that has the most talks ever compared to any other, like, you know, product security firm or cyber consulting firms. We do bug bounty, and out of our diverse client base, there's also, like, you know, catering to all different verticals, right? Doesn't have to be just software-related companies, but manufacturing, utilities, and things like that. Also a dozen books. That's some of our alumni and some of our actual like consultants have written, and obviously a lot of pen tests, and a lot of popular security tools, including cloud security tools like Scout Suite, if you've heard of it, right? Very popular AWS configuration review tool. But that's just a quick primer on NCC and how it fits in into the security consulting realm for securing open source security software. All right. Yeah, so this is, again, just a quick slide on the different types of practices we offer. We mostly spoke about infrastructure, source code reviews. There's obviously specialty practices, which is where I fit in the company, application security, risk management, bug bounty, crypto, hardware, IR, and different things like that. So security is, like, you know, you have different verticals even within security, right? Just to emphasize the kind of services we offer. All right, so that's me. And if you're interested to talk anything about database security, infrastructure security, or anything security, just reach out to me. I'll be hanging out at the HTAP Summit. Super excited to do this talk. Thank you.